Hello again. Today I'm going to show you something cool. Just hold on for one moment. So here's the game so far, but so far it's been very ephemeral. Every time you load the game, you fall out of the sky in the same spot, and everything looks sort of brand new and pristine. And if you dig out some stuff, you level this hill a little bit, and then you restart the game, and your changes are gone. So in preparation for some other changes, I wanted to implement a loading and saving system. So now, if you hit Control S, it does a save in the background, and if you run around a bit, go on top of the hill, you load. It now puts you, back at the bottom of the hill, and you can see everything here is there's still the hole. And if you restart the game, you now are, it's loaded. And then it loads, like, the game is very simple, but it loads pretty quick. It takes, the first load's a little bit slow, takes a few frames, but the subsequent ones take between 30 and 60 frames, milliseconds. So I want to talk a little bit how I accomplished this. First, the boring bit. In the player controller system, there's a variable save requested and load requested, and that defaults to false. But if you press the S key or the L key while the left control is pressed, then it sets that save requested to true and false. And then in the game, in the main game object, after the engine is run, I check to see, hit save if requested or load if requested. I did this outside of the engine update because these things can make heavy use of the engine, but they could also work just as well inside the engine as a system, I think. So save if requested, checks to see if that flag is set, and if it's set, then it sets it to false, then calls save. Same thing for load. Okay. So, when I was browsing around online, I was searching like how to write a save or load system. And something that comes up is serialization. And this is serialization is taking your in-memory data structures and turning them into bytes. And then with these bytes, you can either send it over the network to another machine for multiplayer, or you can use it to save state on disk. And in any case, you can take these bytes and you can deserialize them into regular objects, just like what you had. It's just a way of persisting state, to either the network or to your hard drive. So my first inclination here was to serialize everything. Like, take your entities and iterate over every entity and every component and just serialize it all. However, that turned out to not work very well. So if you look at the player, there's some things that you can serialize pretty easily. There's the player component, which is it's all just booleans and floats. And hold on, whoops. Okay. It's all just booleans and floats, and it's they're primitives, so that's easy. But if you look at some of these other ones, like animation component here, it's texture regions and arrays of texture regions, and there's also the physics object, which is various circles, just shapes, and these are J and I objects. You can't serialize them. If you look at the texture region, like, no part of the texture region actually keeps track of the file name. It doesn't actually know where the file is. It just gets passed a texture. Even the texture doesn't know what file it came from. It gets passed a file handle, but all it does is immediately call load from file and turns this file handle into texture data. And so it's completely lost. It doesn't know where that texture came from. So my initial inclination was to update the texture component in my code to accept both the texture and texture descriptor. And the texture descriptor would have the file name, and if it was a texture region, it would have the texture. It would be a texture region descriptor that would have a reference to a texture descriptor, as well as an x, a y, and a width and a height. And I kept fighting with this for a while. I didn't even get as far as physics bodies, but it turned out to be a real headache. But thankfully, it turns out that that's not actually really necessary. And the easiest way to sort of come to that realization is you don't actually need to save all the graphics information. You don't need to save the name of the textures. You don't need to save the physics objects. Really, you just need to save not the differences, but what makes that game, this particular instance of the player's experience, unique. So anyway, so more concretely, I create a file called out.save. This is in the save game method. I create a file out.save because this is Kotlin. It works by using extension methods off a file. So I create an output stream and I buffer it, and then I do some compression stuff that I'll show you later. And then you wrap it. I'm using Cryo, and it's pretty cool. It's very fast. It's just I think it's moved. Yeah. It's a serialization library for Java, and basically you give it a class and it turns it into bytes for you. It's the usage is a little bit tricky at first, but it's pretty. You'll get the hang of it. Anyway, so once you have a stream of some sort, a file stream or whatever, you wrap it in an output object. An output is sort of the main stream. It's the main stream wrapper that Cryo provides for writing. So you do sort of have to pass it around everywhere. So, and by calling use, that ensures that output is closed at the end of this block. If you don't close output, your save file will get corrupted. So write version. So this is how you use Cryo. You say cryo.writeObject, and then you pass in the output object and the version. And Cryo has a lot of sort of, if you've ever used Jackson, which is for JSON serialization or anything like that, there's a lot of sort of meta configuration that goes on about how you serialize things, and that's all encoded in Cryo, the object. But if you look here, there's also, depending on what exactly you need, there's other various write methods. If you write this, you have to know what type. When you read it on the other side, you have to know what type it is. If you're writing an integer, you have to say, okay, I am reading an integer when you load it. If you don't know exactly what type it is, if it varies at runtime, you use write class and object, and then on the other side, it'll read the class and object, and you'll have to cast it, but at least it'll know what it is. It can't guess for you; you have to tell it. Anyway, so all write version does is it writes out a version number. It's just 1. Okay, so moving on. There's really only 2 things when you run this game. There's only really 2 things that vary from game to game. Right now, there's where the player is and which direction they're facing, and also what blocks of terrain have been dug out. Nothing else really varies from game to game. If you look at the background and the lighting effects, you don't that's going to be the same. Eventually there might be like a day-night cycle, and I'll need to save what time of day it is. But right now, it's always the same, so you don't actually need to save it. So you need to save what type of the terrain is and where the blocks are. So if you look at save player gets all entities that have transform component and player component, and anytime you're writing out a list, so right now this list is always going to be size 1, but anytime you're writing out a list, you have to tell yourself, the save file that gets read later on, you have to tell it how many elements to expect in that list. Because on this side, we can just loop over everything and just keep writing. Well, on the other side, you have to know how many times to loop. So you just say, player set size, and you write that object out. And then for each player, I serialize player and transform. And this works pretty well. You can just serialize the components directly, and this works pretty well provided that you never change those components. If you're going to add additional fields onto them, the serialization can actually break because the default field serializer, I think, assumes that you have the exact same fields before when you're serializing and deserializing. So I might not, stick with this for compatibility reasons. Transform component. So player component has whether you're moving, which direction you're facing, how long you've been moving, whether you're on the ground or not. None of this is actually really that important. The only thing here that really is mildly interesting is which direction you're facing. But so I could almost just not save this component at all. Transform component's a little bit more important. It's positioned and angle. Well, angle is always the same in scale. In scale, position, angle, and scale. So I said you can just serialize the components, but this can have problems. Something else that you might consider doing that I will probably do at some point is just create a simple little data class that says just position and is something like this, and just something that's very generic, and then creating a position object that describes the transform component, and then you can change the transform component all you want, more or less, but the position component can never change. And it should be sort of logical enough that it doesn't need to change. And if you need to add more data, then you create another class. If you decide you need an x coordinate, you don't modify position, you create another, sorry, did I say x? Z. And then this way you can just sort of, you can add without having to, modify. Anyway, so I'm doing components for now, and we'll probably regret it, but that's, fair warning. So player was pretty straightforward because all I really needed was transform. Terrain was a little trickier because the way I was building up the terrain, you pass in this two-dimensional array of terrain types, and you just iterate over it, and you just plop these entities directly into the game. But there's no information on those entities about how to sort of work backwards, go from the entity back to the original description. And you can maybe take the transform component and convert it back, take the x and y coordinates of the transform and sort of just convert them back into integers. But the transform might be offset. If you remember, this build class here takes an offset here, and so the position of the body, it's it might be at 1010, but the original coordinate that was initialized with could be 5, 5. So the current physical position is not actually indicative of what was used to create it. So that's why all I did was I created another terrain component, and it's just it has a terrain type, and it has the width and the height. It has the x and the y position, which is just w and h here, sort of confusingly. I'll change that eventually. And that way you know exactly where that terrain is, what it was initialized with. One other thing that I ended up needing, and I added this as an entity, but this is not a great use of entities. I needed to know what parameters this build method was originally called with. I needed to know how big the two-dimensional array is, what this offset and size are. And so I just created an a component that is used in just this one place called terrain world description. And it has those exact things. It has dimensions, offset, and size. And so I add that entity to the engine, and it just sort of lingers. I could have made this a field on Game World Builder itself, up here somewhere. But this isn't. It's not terrible. It doesn't slow down the game at all. It takes a little bit more memory, I guess. But since none of the systems are actually iterating over it, it doesn't actually slow down the game. So, yeah. So for terrain world description, so in save terrain here, I call get entities for terrain world description, and then I call first, because there's only one, and then I call get terrain world description. So this gets the terrain world description component off of the only entity that has it. And then because it's basically like float is a primitive and vector2 is just x and y basically. I just straight up serialize the entire terrain world description here. Cryo.writeObject. And then I iterate over everything that has a terrain component, and I save the size there. And for each one, I look up terrain component and I just save it. And remember, terrain component has terrain type and width and height. Terrain type here is an enum with type dirt, is the only value right now. If you ever wanted to, the problem is that this couples it to your actual application code, and if I wanted to change it from dirt to something else, then it's going to not be able to deserialize it. However, if instead of this being a terrain type, instead of it was a string, the string dirt, then you'd be able to deserialize it into the string dirt, and then figure out, oh, we renamed this into this other type here, or something like that. So you got to be really careful that about compatibility if you want to care about that. Okay, so that's it. It prints out how many terrain tiles it saved, because why not? And then it closes and it says how much time it took. So if you do this, if you run this again, you do a save. It saves, about 5,000 tiles, and it takes about 130 milliseconds on the first try and like 40 on the second. To load, you basically do all this in reverse. There's a few things you have to do first. I nuke everything in the engine. Basically, I have to reset all the global state. So I nuke everything in the engine, and the ray handler, which is what handles all the light rays, I remove all those. It just kills all the lights. And World, unfortunately, doesn't have a good way of resetting itself. You can call a world.dispose, but I think this completely makes the class unusable. So the question is, how do you reuse the world without... how do you nuke everything and start over? I created an extension method, remove all bodies, and the way it works is you instantiate an array, and you pass it to get bodies. This is on the world object. You call world.getBodies, and it resizes the array for you, and then it iterates over all the bodies and adds them in. And then once you have all the bodies, you call destroy body for each one. And I think this is actually, it seems sort of crappy, but the important thing is when you call destroy body, it makes various, it destroys all the joints on it, and it calls the JNI call to destroy the body, and it calls, it resets the user data, and it removes and frees all the fixtures. There's a lot of cleanup stuff that it actually has to do. So that's not, I don't think there's any way, if you just instantiated a new world and let the old one get garbage collected, I don't think it'd actually get garbage collected. I think it would just hang around forever, pretty much. Or it wouldn't get cleaned up correctly. Anyway, so after you nuke all that stuff, you do input stream.buffered, and then the compression stuff, and then instead of output, it's called input. And here I'm just reading and asserting the major version. I read in the integer. One thing that's really important with Cryo is it doesn't know anything about what's in the data stream except what you put in there and what you tell it about. So if you write something and if you write X, Y, and Z, you need to read it back in that order. Otherwise, you're going to get the wrong data or it's going to crash. So because I wrote, if you go back into the save game, I wrote the version, the player, and the terrain information. And for player, I wrote the count and these pairs. And here I wrote the count of terrain and the terrain component. You have to do all that exact same stuff in the same order very carefully, otherwise it'll just not work. So over here I read the version, and I do a Kotlin check that throws a illegal state exception if it's not equal. And then I call load player. The first thing load player does is it reads in the number of players that we have, and then I say for I in player count, 1 to player count, which loops the right number of times. I call a read object player component and transfer component. And so now the trick is, what do you do with this information now that you have these two components? Because the player needs a lot of other components in order to function. So the way I've been doing it so far, that's been working all right, is if you look at like game initializer, when you start the game, it calls create player, create terrain, create background, and create lighting. We basically want to do all of these things again ourselves. You could modify player to take these additional parameters, but because it's just an entity, you can just overwrite the settings that it was created with, which is pretty easy. So create player already exists here, and it already sets up everything we need. It sets things to the wrong position for us. Oh, by the way, if you look at add calls add internal. This is inside entity, and here it says if you're adding a component, first it gets the current component on the entity that matches this class, and if it exists but it's not equal to the thing you're about to add, then it just calls remove. So basically, if you have a transform component on an entity and then you try to add another transform component, it overwrites the first one, which is great. That's what we want. So if you want to, so you can just reuse this method here. So we call it create player. Create player creates and adds the player into the world. And then I add to it player component, which has the new player component we just loaded from disk. And normally I would just call add transform component, but if you recall, transform component is synchronized with the physics object. So if we set the transform component, it'll work for like half of a frame, and then the physics object will come by and synchronize over it. So really what you want to do is, based on the transform component, we want to move the physics object to the right spot. And then on the following frame, the transform component will be synchronized correctly. Yeah, so that loads the player. And then the terrain, what we want to do really is call the game world builder again with a correct, with the same offset and size as we had originally, and a different terrain array. So here what we do is we read in the terrain world description, and then we create a two-dimensional array that's full of nulls, but is a array of terrain type question mark. And then we read in the number of terrain bits that we have, terrain tiles, and then for each terrain count we slurp in this terrain component. And remember, terrain component has type, the X and the Y location, which is what we need. We just after we have this fully populated, after we have this big null two-dimensional array, the next step is to just start populating it with data that we have. And so we just iterate over this, 5,000 times, roughly, and start sticking data in. And then we finally call gameworldbuilder.build, and we pass in the data we just collected. And then, because the background is the same, no matter which, no matter what, I just call it create background, and then and the same thing with the lighting. I just call it create lighting. Like I said, if the lighting is different, then you need to save. You don't need to save all the lights necessarily, but you need to save, time of day, or just you'll need to tell it to reinitialize all of the objects that have a light component attached or whatever. But overall, this was a lot simpler than what I was originally planning. Uh, I have the saver class, the loader class, and it's like 200 lines of code. It's really for the basic stuff, it's really not that bad. So that was Cryo. One other thing that I thought was interesting was I wanted to also compress the resulting data, because in the previous iteration, when I was trying to when I was trying to save everything, it turned out to be it was like 800K or something for just for the most basic game. So the library I'm using is called LZ4 Java, and it's this really fast compression, low memory. Like I think it's mainly for sort of compressing network traffic in a very minimally invasive way. But you can use it for anything. You just hand it, as you can see here, you just hand it bytes and it compresses it, and you can do whatever you want with it. Anyway, so what I was doing here is in my cryo holder class, I have a sort of a global compressed, and if compressed is true, then when saving, I wrap the stream. All you have to do, like, there's an output stream wrapper that handles everything for you, and so you just wrap it in LZ4 block output stream. This is the default fastest available compression mechanism. There's like a JNI version and a non-JNI version and an unsafe version, and yeah. So it picks up the fastest one that it can. And I have the same thing on the other side, LZ4 block input stream. And I haven't actually checked, since I rewrote this, I haven't actually checked how much it saves. But like here, when you save data, it's a lot smaller now, thankfully. It's 27 kilobytes. And if you compress it, it's 19. It seemed like anecdotally it seemed like it was slower, but when I was running this before, it would take 100 milliseconds to generate 800 kilobytes of data, and then it would take like 0 to 1 milliseconds to actually compress it. So I'm not sure this is really representative, even though this number is higher than it was a second ago. I think the compression is really fast. So one other thing, Cryo doesn't know how to serialize everything that you give it. Especially doesn't know how to deserialize everything that you give it. Like, for example, the transform component here, if I don't tell it how to serialize transform component, then you can save it just fine, but when you try to load it, it blows up. And the reason why it blows up is it says class cannot be created, missing no arg constructor transform component. So if you look at transform component, there's like 4 constructors, but nowhere here is there this sort of a constructor. There's no empty constructor, no arg constructor. And that's on purpose because position is immutable. I don't want you to be able to set the position afterwards. And that's just in general, it's a recurring theme with as many of my components as I can. Always use immutable state. And that's great for, I think, general programming design. But it does tend to confuse serialization programs because we want to just instantiate it with the no-arg constructor and then use reflection or something to set all the properties on it afterwards. And because it doesn't know what the constructor order should be, it doesn't know about the names of these parameters or anything. So it fails, and then the solution is you just say, you call register, which means whenever you encounter transform components, use this serializer. And it's pretty easy. You can see here, you just say cryo.writeObject, and you just pass it each of the different properties that the component has. Yeah, and like if you look at transform component, it's position, which is a vector 3, angle radians, scale, which are both floats. So vector 3, float, float. And then on the other side, for reading it, it says, okay, I have some bytes here that I think is a transform component. Turn it into a real transform component. And here I just say, I instantiate the transform component, and then because constructor arguments are evaluated left to right in terms of expressions, I can say read object vector 3, read object float, read object float. I could just as easily say something like this. This is just as correct, and frankly, it's a little bit easier to to verify correctness. But if you want to be a little tricksy, you can just do it inside the constructor like this. And now the game it'll know how to. It won't try to serialize it using the single new instance method, the no-arg constructor. It'll actually just call read instead. These are basically exactly the same. There's one for terrain world description and one for terrain component. I happen to write player component as well. But player component has a no-arg constructor and a bunch of var states, so it doesn't actually need a special serializer. If you were to try to do something crazy like serialize physics objects, you would also need to have something like this so that you can, because the way you instantiate the physics object is by saying world.createBody, and it's not going to possibly know about that, so you need to tell it that you don't just call new necessarily. You can also call factory methods like this. The last thing is if I ever want to do this on somewhere that Cryo isn't available, like iOS, I guess, or in the browser. I wanted to make this a little bit more generic, and so I have an interface loader with load game, an interface saver with save game, and this way, in the game save manager, it doesn't know yet that I'm using Cryo at all. If you sort of ignore this stuff, it just sees saver and loader, and it's up to Juice to figure out where those come from. And the way this is set up right now is I don't have a module. I don't tell it to, in main module, it doesn't bind Cryo. It doesn't bind Cryo saver to saver. I just say implemented by, and that just means by default, anytime you ask for saver, by default it just gives you a Cryo saver. Later on, I might have a custom module that gets loaded for each platform. And for the GWT platform, or the HTML target, it'll have a different saving mechanism. But you'll still just call save game, and it'll work similarly, except it won't use Cryo. It'll use local storage or something else. Okay, well, that's it, and I hope this was useful. So good luck and happy saving.